Hello and welcome. This is Chemistry 111, Chapter 1, and we're doing an introduction to classifications of matter. So this is Part 1, where we're going to classify matter by state and by composition. Some of the abbreviations that are going to be used in this course, we have MLCL for molecule, ELT for element, and CPD for compound. All right, let's start with definitions. So, chemistry. Chemistry is the study of matter and energy. And we need both of those things together because in order for anything to happen to matter, there has to be energy involved. Matter we're going to define as anything that has mass and occupies space. An atom is the smallest particle of an element that retains the chemical properties of that element. And a molecule consists of two or more atoms chemically bonded together. And we'll talk more about atoms and molecules as we go along. All right, so we're going to classify matter. When we classify things, we find different ways of understanding. So we can classify things like, for example, people. We can classify them by height, by age, by occupation. And those three different ways of classifying tell us different things. They give us different information. So that's what we're going to do with matter. We're going to classify it. And in this particular lecture, we're going to look at physical state and we're going to look at composition. The properties of matter we'll look at in a different lecture, lecture part 2. All right, we'll start with the states of matter, and we're going to talk about 3 states: gas, liquid, and solid. So a gas has no fixed volume or shape. In a gas, the particles are very far apart and they're moving very fast. When I say very fast, if we have a large, for instance, a large lecture room, the molecules of gas in the air are moving at about 400 meters per second, which means they can move about 5 times around the room every second. So that's pretty fast. A liquid has a distinct volume but no shape. And in a liquid, the particles are closer together and they can flow past each other. A solid has definite shape and volume. A solid is considered to be rigid, and the particles are close together in fixed positions. Now, to change between states, we can do that by adding or removing heat. So, for example, we have 3 pictures here showing matter at the molecular level, at the microscopic level we might call it. In a solid, the particles are close together. If we add heat, those particles move a little bit further apart and we get a liquid. If we add more heat, then those particles become a gas, and they're very far apart, they're moving very fast, as I said. If we remove heat from the gas, we get a liquid. If we remove heat from the liquid, we get a solid. Notice that one fundamental difference between the 3 states is the distance between the particles. So in a solid, they're close together. In a liquid, they're further apart. And in a gas, they're much further apart. So let's look at the classification of matter by composition now. And there are 2 types of matter by composition. One is a pure substance and the other is a mixture. Each of those has 2 different categories of pure substance. We can have an element or a compound, and with a mixture we can have heterogeneous or homogeneous mixtures. So let's start with pure substances. And a pure substance is matter with fixed composition and distinct properties. There are 2 types of pure substance. One is an element, and an element is composed of only one type of atom. Remember, we defined an atom as the smallest particle of an element that retains its chemical properties. A compound contains 2 or more kinds of atoms in fixed proportions. So let's talk about elements. Elements, as I said, are composed of only one type of atom. Different elements have different natural abundances. For instance, oxygen makes up about 50% of the Earth's crust, whereas francium, which is another element, is radioactive, and at any one time there are maybe 6 grams on the entire Earth. Elements can't be broken down chemically into different substances. So if you do a chemical reaction, you're not going to get anything more basic than an element. Each element has a chemical symbol, which are arranged on the periodic table by properties. We'll talk lots more about the periodic table. The symbol for an element consists of one or two letters. The first is always capitalized. The second one is never capitalized. So for example, C is for carbon, O is for oxygen, Mg is for magnesium. Notice the first letter M is capitalized, whereas the G is not capitalized, so you could not have capital M, capital G. That would be wrong. Fourth example is calcium, Ca. All right, now you need to learn the elements and their symbols. So what you need to know is, given the symbol, you have to be able to supply the name. So for example, if I give you C, you have to know that that's carbon. Or given the name, supply the symbol. So if I give you Ca, then you would know that that is calcium. And for the first test, you have to know the first 36 elements on the periodic table. Notice that this does not mean you have to memorize the periodic table. Please do not do that. You will be given a periodic table for the test. It won't have the names of the elements. You are expected to know the first 36. If you have any questions, please ask me. The second type of pure substance is a compound, and compounds contain two or more kinds of atoms in fixed proportions. A compound has a fixed composition. In other words, it is always the same. And another thing about a compound is that it has different properties from its elements. For example, table salt is made up of sodium and chlorine. You know the properties of table salt, you're familiar with it, it's white crystal, you put it in water, you get salty water. Sodium, on the other hand, is a soft gray metal. If you put it into water, it catches fire. Chlorine is a green gas. If you breathe it, you die. So you take this soft metal, this green gas, you put them together, and you get table salt. Another example is oxygen and hydrogen making up water. Oxygen is a gas, a colorless gas. Hydrogen is also a colorless gas. If you light a match to hydrogen in the presence of oxygen, you get a very satisfying explosion and fire, versus you put them together and you get water. And you all know what water is like. You put a match into water and the match goes out. So remember that the properties of a compound are very different from its elements. The components of a compound are chemically bonded together. A compound can be broken down into separate elements by a chemical reaction. Compounds are expressed by chemical formula, where you take the symbol of the element and a subscript tells how many of each one there are. So for example, water is H2O. There are two hydrogen atoms bonded to an oxygen atom. Hydrogen peroxide is H2O2, and that has two oxygens and two hydrogens all bonded together. Each compound has a unique formula. Any pure substance, no matter how or where it's made, has the same composition and properties. So it doesn't matter if the substance is natural, doesn't matter if it's made in the lab. If it is a pure substance, it is exactly the same. So for example, if you take vitamin C, if you have natural vitamin C, it is derived from rose hips or some other substance like that. If you have synthetic vitamin C, it's made in a lab. Both of those cases, vitamin C is vitamin C. Now the pill might be different because the natural might have other substances that work differently. But if it is a pure substance, it has exactly the same composition and exactly the same properties. A mixture is another classification by composition. A mixture is a combination of two or more substances that each retain their own chemical identity and properties. So when you put a mixture together, the different components keep their own properties, as opposed to a compound where they change. The composition of mixtures can vary. So you can have, for instance, a mixture of salt and water. You can have a lot of salt, a little bit of water. You can have a little bit of water, a lot of salt. Doesn't matter, it's still a mixture. And the components of a mixture are not bonded together. There are two types. You can have a homogeneous mixture, and a homogeneous mixture is uniform throughout. It's also known as a solution. A heterogeneous mixture is not uniform throughout. It's not the same throughout. You can think of heterogeneous mixture as, for instance, lumpy. Let's look at some examples. So here's some examples of homogeneous mixtures. Wine, lighter fluid, tea. These are all uniform. There's no lumps in them. They're all mixed together, but they're not chemically bonded. Here are heterogeneous mixtures. A junkyard, you just got a whole bunch of different things, pond or swamp water, oatmeal with raisins. Anything that is lumpy, that is not the same throughout, is a heterogeneous mixture. All right, now one thing you're going to have to be able to do is visualize matter at the submicroscopic level. So, for example, if we look at atoms of an element, the atoms, we have little orange circles, meaning it's just one type of thing. Just one thing. Molecules of an element, we could have, for example, two of the same element bonded together. And since they're touching each other, we think of that as a bond. Molecules of a compound, we have two different types of element in this particular compound. And on the far right, we have a mixture of elements, and we also have a compound in there. So here is an example. Let's try to identify which of these are pure substances and which are mixtures. And let's start with B, because in a sense that's the easiest. So if you look at B, is that a pure substance or is it a mixture? And since there's only one kind of thing in there, it's definitely pure. All right, so let's look at A now. A also only has one kind of thing. We have essentially molecules made up of one black and two white elements, whatever they are, but it's the same thing all the way throughout, so that is also pure. If we look at C, C contains all the same type of element, because we're considering they're all red, so it's all the same type of element. But in one case we have one atom, in another we have two bonded together, and the third we have three. So that would definitely be a mixture. If we look at D, D has two different elements, and therefore it has to be a mixture because they're not bonded together. E is also a mixture because we have different compounds there. All right, now let's take the same thing, these same pictures, and identify whether they are compounds or elements. So we'll start with A. What do you think? Is A a compound or an element? It's definitely a compound because it has more than one type of element. B, B is an element. C, C is also an element. It's a mixture, but it is only one element. D is composed of two different elements, and E is composed of compounds. So you need to be able to answer questions like these on quizzes on your test. The next lecture will look at classifying matter by its properties.